Let's now consider lenses. And we're going to do that by using ray diagrams. And there's different ways of drawing them, but I will do it the following. So you always have an optical axis that goes, in this case now, from the top to the bottom. You can also draw it from the left to the right. And the light comes from the top, in this case, let's say, from the gun. And I'm going to draw a lens like a line with two arrows at the back. There's people that also draw it as a flat circle, as an ellipse, but in this case I will use this symbol for the lens. Now what a lens does is it bends the light. So you have your light that goes through the optical axis, through the center, but there's also light that goes through the side of the lens and similarly to the other side of the lens. And your light can be diffracted or bent more and more, but you have all these rays that go through the lens and enter it. Now what a lens does, it always has a focal point. So a perfect lens will focus all these rays that come from the same point again in the same point. So you will have a focal point of this lens. And these rays will go here, and these rays will go here. And then also for this one, and for that one. So this is a perfect lens. If we change the strength of the lens, so in a glass lens you cannot change the strength of the lens. The glass lens has one particular lens strength and also one focal point. In an electron microscope, the lenses are electromagnetic and the strength of the lens is determined by the current that goes through it. We can change the strength of the lens and thereby also we change our crossover or our focal point. So if we make the lens, so we draw our optical axis again, here. If we make the lens stronger, what it will do is it will bend the light further. So if we have a stronger bending, what we end up with is a situation like this. And the same focal point. So a stronger lens will have a stronger bending. And what you've seen now, that what happens is that this crossover moves up. Obviously, if we have a weaker lens, let's draw the optical axis again. A weaker lens will bend the light, or in this case the electrons, less strong, so further down the optical axis, and therefore the crossover moves down. So you have this crossover that moves up and down, like so, if we change the strength of the lens. So that's the first thing that you have to realize. The second thing what we can also see is that when we look at a certain image plane, like here, we would see that the image here is like this big. The image here is this big. And we cannot even draw the larger one because that will be the entire field. So what happens if you change the strength of the lens? The crossover moves up and down, and if you place your image plane fixed somewhere, the projection of that with the crossover moving up and down becomes smaller or larger. So a weaker lens has a small projection, and a stronger lens has a larger or very large projection. When the crossover moves up and down, the projection goes from small to large. And that basically is magnification. So this spot here, whether or not it's a spot of your condenser system, or whether or not this is the objective lens, and this is a projection of your image, is magnified. So a lens, if the crossover goes up and down, magnifies the projection of either the image or the spot, depending on which lens it is, on your image plane. Let's now consider two lenses. And we're using an electron microscope. So we start from the top. We have the gun. And after the gun, we have our first condenser lens that condenses the light. So we have here our condenser lens 1, C1. We have our optical axis going through the center. And we have our C2, our condenser lens 2. So we have a two condenser lens system here. Now what will happen is that the light comes, the electrons actually I should say, come from the gun and they get focused in a certain point here. And this point is your C1 focus. So that is your spot size. And if you change your spot size, you can understand that this crossover, this focal point of that lens, moves up and down. So if we would have the same amount of light or the same angle of the electrons going into this first lens, and we change the spot size, for instance, to a weaker lens. Let's assume this is spot size 9. And we go to spot size 3. So we make the lens weaker. That means that if you basically look at my arms, that the lens does this. And the crossover, which is the cross between two of my arms, goes down. So if you have a weaker lens, like so, the light is bent less. Yeah, so here the angle is less strong, so less bent. This is a larger angle. This is spot size 9, has a smaller angle, and spot size 3 has a larger angle. And you'll see that the imprint also is different. So the amount of light that enters your condenser 2 lens is different. The plane where you have your crossover has also moved. So this is spot size 9 and this is spot size 3. Now when the microscope is aligned, what we make sure of is that when you change the spot size, you see that the current, the percentage going through the lens, that changes on the microscope for C1. But you also see a change, be it small, in C2. Because if you change spot size, you don't want to have a different projection, a different spot actually on your specimen. You want to have that the same. You only want to change the spot size and nothing else. So what the C2 lens does is, the C2 lens of course also focuses the beam to a specific spot. But if you change the spot size, your C2 lens adjusts so that the crossover is in the same location. Right, like this. You see here that at the same image plane, You also see that the weaker lens, C1, your smaller spot size, has a smaller spot in your projection after C2 than when you do spot size 9. That is a larger projection because we adjust the C2 lens such that the crossover remains constant if you change the two spot sizes. So here your crossover remains at the same location. So if we change spot size, we actually don't change C2. We do change C2, but we only change C2 to compensate for this smaller beam that enters the lens. So we make sure that the crossover is in the same location. So this is what happens when you change spot size. Now there is something more that happens when you change spot size. There is also a hole or an aperture that is just behind the C2 lens. And this aperture limits the beam, so we're aperture limited, C2 limited. So this tiny aperture blocks a certain portion of the beam. If we look at spot size 9, so that is the larger beam, then the amount of light or the amount of electrons that it blocks is basically all of this and all of that. If we look at spot size 3, let's use a different color, then the blocked amount is only this. So the percentage of light that is blocked by the C2 aperture for the beam that has a larger spread is bigger for the spot size, so for the spot sizes where the beam is bent stronger. So the stronger this beam is bent, if we go to the extreme case, if we bend it really strong, like so, this is the extreme case. Let's make the lens bigger. Also here on this side. And this is then focused in the same spot again. Same point here. You can easily understand that now, oh, this is my aperture. Almost all of the light here, almost all of it, is being blocked by this aperture. So if you increase spot size, the spot size goes up from spot size 1 to spot size 12. You will see that this crossover moves up. The beam is bent stronger, and therefore the aperture that is behind your C2 will block more of the light or more of the electrons that are coming out of your C2 lens. So what effectively happens when you change the spot size from a small number to a large number for TEM is because the beam is spread so far, the aperture is blocking a larger percentage of the electrons that is allowed to pass through this aperture coming from the C2 lens. And for the TEM use case, so what we use it for, this allows us to control the amount of electrons that hit our sample. And since this is per time unit, this is our dose rate. So by changing the spot size, the aperture makes sure that the dose rate is effectively changed. So a larger spot size number is a stronger C1 lens, So the different spot size going to spot size 12, we have a stronger C1 lens. And consequently, we will have less light per time, less electrons per second coming through our C2 aperture. And therefore the dose rate at high spot size numbers is low. And the dose rate at low spot size numbers is high. Let's now look at gun shift. Obviously, when we start imaging on an electron microscope, we need to make sure that we start correct from the top. So our gun produces electrons, and those electrons should go along the optical axis and through the center of the lens. Now it's a mechanical piece, so that can be shifted to the right or the left. And then our light will not, or our electrons will not go along the optical axis. So we have to align this in order to make all the electrons go nicely along the optical axis of the microscope. So let's now draw the situation looking at the condenser system. So we have our C1 lens, and here we have our C2 lens. So condenser lens 1 and condenser lens number 2. If we now draw the electrons that go through the center of this lens, but with a shifted gun, then it looks like this. So let's assume now that our crossover of spot size is here. So this was our crossover. Remember, light goes through the center of the lens and the other light also comes there. So our crossover, we draw that now here, but I now only draw it with the central beam that goes to the center of the axis that is not bent. The other light is bent and will also be focused there. But for simplicity, I'm only using or drawing the beam now that goes through the middle of the lens, so that always goes in a straight line. And the crossover of our first spot size 9, is over here. Now this beam goes through the middle of the lens, so we can also draw that beam continuous, so it also goes through the center of the lens here. And it will end up somewhere on my image plane. Let's say I'm imaging this over there. If we would change the spot size now, if we change the strength of the lens to a lower number, a weaker lens, spot size 3, then our crossover would end up, maybe use a different color. So the light or the electrons also go through the center of the lens. So our crossover will end up here. If we then go also through the center of this lens, we will end up over there. So now what we effectively have is this situation. Now, if we look at the bent light, you can see where this is coming from. It's coming from here, and that then has to come from the same origin. So that is something like that. What now effectively happens is this distance here is magnified. So if you change the spot size, what you'll see is that actually your spot will move. If your gun is shifted and you have your light on the screen, so this is our fluorescent screen, and we have a nice spot of the electron beam. Maybe we want to make that green, because it's a fluorescent screen. You have your spot here. If we would change the spot size and our beam would be shifted, then that spot would move. If we go from spot size 9, where it would be closer to the optical axis, to spot size 3. So you can see whether or not your gun is shifted by making the beam to a small spot and then changing spot size from 3 to 9. Because then you will see that your beam will shift from this location to that location. You see it move. What you can then do is when you go to the larger shift, so when you go to spot size 3, you can then use your gun, you can activate your gun shift and move the beam back to the center. Yeah? So you of course need to start from the middle. So what you can try in this routine is you can use a beam shift. So when you make the beam to a spot, you can use your beam shift to bring that spot to the center. So just easier for you. It doesn't do anything, but it's easier for you to see that we start from the center. And you do this with spot size 9. And then you switch to spot size 3. You'll see that the beam will move away from the center. And you activate your gun shift. And you then move with gun shift. You move that spot back to the center. And then you are in a better situation, because then the gun has been moved closer to the optical axis. Let's then take again a different color. So we're now closer to the optical axis. So now the situation is like this. So if we go down here, like so, spot size 9, and through the center, we end up here. And with spot size 3, so you have improved if you take spot size 9 and it's very, very bad, and you use gun shift to bring this back to the center, then you have improved the situation. The reason why you're not straight at the middle is because you start off with spot size 9 and your gun was shifted. So spot size 9 was not in the center. You only used beam shift to bring that spot to the center to more easily see where you have to go. So what you basically have done is you move spot size 9 to the position of spot size 3. That is not yet the center, but you have improved the situation. So the gun has shifted closer to the optical axis. Now if you iterate this routine, you go to spot size 3, then again center that with beam shift to find the nice center, go to spot size 9, go back to gun shift and bring that spot back to the center. So you have to iterate this routine and you will get closer and closer and closer to the optical axis, until this shift is so small that we can assume that the gun shift is properly corrected. You can do this by hand in the direct alignment yourself. If you now understand what is going on, you know why you should shift between, or why you should toggle between spot size 3 and spot size 9, and why at the higher spot size you have to use gun shift to bring it to the center, and with the lower spot size you simply need to find your bearings and you use your beam shift. So this iteration between these two spot sizes you can do yourself. Now you can also do this in the gun alignment routine, where you are guided through the routine and it will tell you in a specific step to bring the beam to the center of the flue screen. And you might notice that the microscope toggles between two spot sizes. So again, effectively this is what you're doing. It will also tell you that this step will iterate until the shift is small. So the microscope itself in this routine will determine, because we know when it is good enough, when to stop. If you do this yourself, then you have to decide when to stop. So I always advise to just do the gun alignment routine always, but you can also do this from the direct alignments if you know what you're doing. But this is what happens when you align gun shift.